you will notice that most of nature's chemistry is water-based, not based on any other toxic materials. Nature runs on information. We'll talk about this a bit more, how fascinating this is. Nature builds using abundant resources and uses rare resources only sparingly. In nature, what is abundant is gold. So whatever is abundant, nature will try to use. Unlike humans, whatever is rare is gold for us. So we will only run after those rare resources. Nature is locally attuned. So whatever is available locally, whatever is happening locally, nature will take cues from that and actually use it. Nature uses shape to determine.
Nature doesn't go all the way to very, very far away to collect marble and build houses in the south of where marble is not available. It's very locally attuned and responsive, and of course, yes, that's one.
And uses shape to determine functionality. So we create our watches saying they look beautiful. You put in a lot of materials and create something merely because it looks beautiful. Whereas in nature, the shape is determined by functionality, not just because it looks great and wasting materials and energy. So now I have just quickly summarized 10 patterns. Of course, there is no this pattern is more important than that pattern, anything like that. I've just shown them to you in some order. But these are also principles that you have to think about if you are intending to be a biomimic. Because when you design, you need to keep these in mind as well. It is not enough. Remember the question we started with. Is biomimicry just about imitating a function? The answer is no. Biomimicry is about also bringing in these patterns into your solutions. Because the whole intention is to create something the way nature creates. Otherwise, we are just adding to the problem. And these patterns, as someone already pointed out, are what will make your solutions sustainable, are what will make your solutions actually stand the test of time instead of creating waste and toxic byproducts and so on and so forth. We will talk about this a little more, as we go along. But I just wanted to leave this with you so that you can start thinking about this. So that's nature's unifying patterns. Now we are saying, okay, we know what biomimicry is. We know that it's about imitating function. We know that we are going to take nature's patterns, what we also would like to call nature's design principles, as we start designing our solutions. Now, you can ask the question.
1 minute, yeah. Would like one of you to summarize what has happened, like what Shivika did at that time. One of you to summarize what all we learned. Now, I'm sorry I'm doing this. I'm a incorrigible teacher, that's why I need this from one of you. I need one of you to summarize it. You don't have to be right, but I need one of you to summarize this to make sure that we're all learning together and we're just not just sitting down without learning. I want one of you to summarize. Just take the lead and summarize. That's it. 2 minutes. Any one of you, not Shivika, but come on. Yes, go ahead. Samsung is what I see.
Is it? I'm Krishna.
Yeah, hi Krishna. Go ahead.
Yeah. So what I see that we have looked at is what are the different forms of bio inspiration that are happening. We looked at what biomimicry is not, and we looked at the various aspects where it's not just about mimicking the nature, the aspects that we really consider when we are using the biomimicking. And now we are probably exploring further on how one can observe those things.
Very good.
That's fine.
Thank you, Krishna. Anyone else?
Yes, sir. I want to add something.
Yeah, please go ahead.
Yeah, biomimicry, it is how we can learn from the nature. So nature is all doing itself and it is evolving from the ages. It can sustain in any environment. So we have to learn, and we can also imply it in our business, our learning, teaching experience, how we can evolve ourselves so that we can adjust in any environment and be productive. Whether it is during the COVID, we try to learn online. So online learning is also very good in learning platform, because we got to learn from different portals like SWAYAM portal, NPTEL portal, and so sometimes an adverse environment can also create opportunity for us to evolve ourselves.
Great. So we will talk about that a bit more when we talk about the nature's patterns as well. So thank you for that. So this brings us.
Jivita's comment is also very good. I'll read it later. Thanks, Jivita.
So what are we? So we've said that okay, we are talking about nature's patterns. We are talking about what is, in biomimicry, we're imitating a function. So what exactly are we going to imitate? What are we going to imitate in nature? So what we are going to imitate in nature are three things. We are going to imitate form, which is the shape, surface, or texture of something. We are going to imitate process, which could be a behavior or the way something is operating. We could imitate system, where there are many forms and processes that are interactive. Now, we will look at examples of each of these, but let us start with, these are three things that we are going to imitate from nature. So the first thing is form. And the most, a very popular example for imitating form is, of course, the Shinkansen bullet train. Now, the bullet train is, when it was created, was the fastest train in the world, going at 300 kilometers per hour. And of course, everybody was very happy with it, etc. In fact, it was called the bullet train because it had this bullet-shaped front of it. The front was shaped like a bullet. Now, the problem that was happening was the noise. So every time the train went through a tunnel, it created this huge boom sound. And all the residents living around the train stations were complaining, saying, what is this? It's creating a huge sound and all that. Now, the engineer who designed the bullet train could have looked at, other ways to solve the problem, saying, okay, how do I prototype a different kind of train, etc., etc. But luckily for us, this engineer was also a bird watcher. So what did this person do? This person looked at the kingfisher. The kingfisher is this bird. And this bird, when it dives into the water, it makes what is called a splashless dive. There is no splash that happens when it dives into the water looking for fish. So this engineer looked at that as a lesson and made the nose cone of the train modeled after the kingfisher's beak, because the principle is the same. You're going from one medium to another without causing a disturbance. So therefore, you will notice that the nose cone of the bullet train is modeled after the beak of the kingfisher. And this is what imitating form is. You're imitating a shape in nature in order to accomplish a certain function which is not causing a disturbance in this case. And it so happened that there were other advantages that happened because of this. The train started traveling 10% faster on 15% less energy because of the aerodynamic efficiencies that it afforded. So this is imitating form. One of the things that we can imitate in nature is form. The second thing that you can imitate is process. In form, you're imitating the shape, surface, or texture. The other thing you can imitate is a behavior or a process that is happening in nature. Again, a very popular example of this is the Eastgate Center in Harare, Zimbabwe. Now, Harare, as you know, is a very, very hot place. The architect was asked to create this office building cum mall in Harare and was told, the architect's name is Mick Pierce. Mick Pierce was told, please do not use too much air conditioning for this building because it will end up being very expensive. Now, again, Mick Pierce ended up being an ecologist. So what did Mick Pierce do? Mick Pierce looked to nature for inspiration. And what Mick Pierce did is he looked at the termite mounds. Now, you may have seen these termite mounds in many places. What exactly are these mounds? They are the nests of termites. The termite nest is underground, and the termites build these mounds on top of their nests. Now, these nests are highly porous. They have a system of channels and vents all along this nest, all along the mound. And what they do is they let in cool air in the night and let out warm air in the morning. And this is the principle, this is the process of gas exchange that Mick Pierce looked at and imitated in the Eastgate Mall in Harare and created a bunch of passive cooling techniques that can be used to cool the building, unlike conventional air conditioning. And because of that, 30% less, bills because of air conditioning as well. Because you can imagine a large urban building like this will actually use a lot of energy for cooling. And by using a lesson from the termite mound, Nick Pierce was able to bring that down.
There's a very nice video on the Eastgate Center that you can look up later on. There's also, if many of you are interested in the intricacies of the technology that was used, there's a very nice video of actually taking a portion of the termite mound, making a mold out of it, and how did Mick Pierce actually come about using the termite mound principles in order to save energy for the Eastgate Mall. The surprising thing is, why is there only one Eastgate Mall? Why are there more and more malls not built around this principle? I think that's a different problem that we have to solve, the way we look at sustainability and all that. But there's a great inspiration for you, the Eastgate Mall and the termite mound being imitated for imitating process in biomimicry. Yes, Minnie.
So that's form and process. System. Now, what you see here is a mangrove forest, right? Mangrove forest is an ecosystem where you have several forms and processes that are interacting with each other, and all of them are being sustained because of each other. And this is being imitated in a process called industrial symbiosis. There is this town called Kalundborg in Denmark, and what they have done is they have created an industrial symbiosis eco park. Now you have many industries in this eco park, and the way this park works is the waste from one industry becomes the raw material for another industry, and the waste from this industry becomes the raw material for the next industry, and so on and so forth. So what happens is the environmental stress on the ecosystem is very low, and obviously reduced consumption of resources as well. They are sharing, they are taking advantage of shared resources and actually have created a system that has reduced waste and is also recycling the waste. So this is an example of imitating system. So form, process, system. These are the three things that you can imitate actually from nature as far as biomimicry is concerned. But remember that in each case, we are going to imitate function. And that's what we started with, right? We are imitating function in biomimicry. Specifically, we are imitating form, process, or system. Any questions before I just move on to talking about function? Because function is something that is the distinguishing factor from between biomimicry and other forms of bio-inspiration. We already spoke about this, green buildings, greenery in buildings rather, and imitating the shape, etc. All these are wonderful, all these are important, but function is what distinguishes biomimicry from biomorphic design or biophilic design. Now, yeah. I'd just like to take a moment here and wait for you to ask some questions that you may have.
Can